Good afternoon, ladies and gentlemen. Thank you very much for coming to my presentation. It is a very big room, and you may not realize, but this is actually the most popular session this afternoon. It's just that because the room is big, it looks a little bit sparser, but you made the right choice. Well, I hope you made the right choice. So with that in mind, let me introduce myself in the session. My name is Rafał Lukawiecki. I don't work for Microsoft. I have never worked for Microsoft, but I have worked with Microsoft for 26 years now. And in the last 11 of those 26 years, amazingly, I have been doing pretty much the same thing. In the past, my job was called data miner, predictive analyst, then it was called advanced analyst. Now it is called data scientist, which is probably the best job title I have ever had. But the work I do really has not changed almost at all. The tools are better. Perhaps I've learned from my mistakes more. I have obviously a little bit more experience now. But in essence, the way I approach my customers' business problems and the way I deliver solutions for them or help them deliver the solutions hasn't really changed that much. And that's what I would like to talk to you in this presentation about. I would like to share with you my Twitter hashtag @rafal.net, as well as my email address, rafal@projectbotticelli.com, in case you would like to stay in touch with me after the session. And I am hoping to make it to the tomorrow's Meet the Speakers event tomorrow afternoon, in case you want to find me over there too. Okay, I would like to focus on the real world, on the practical, applied aspects of what we now call data science. And in between the lines in this presentation, I hope to share with you what I strongly believe our customers expect from us as data scientists or expect from data science if they don't necessarily work with you or I on it yet. Before I go any further, a very quick introduction to my business. ProjectBotticelli.com offers consulting and has offered consulting in this area for a long time. We also offer training. Quite a bit of our training is online. I teach in video courses data science and data mining. My superb colleagues Marco Russo and Alberto Ferrari teach Power BI and data analysis expressions, whilst my esteemed colleague Christopher Webb, the world's expert on multidimensional modeling, teaches cube design, MDX. Carmel and Bob teach Excel BI. And we have an offer for everybody attending the summit and Ignite, offering $50 off our training courses online with a code 50IGNITE2016. However, if you or one of your colleagues would like to learn about doing data science with SQL, R, and Cortana in a more intimate and far more hands-on environment, I have created the first in the world classroom-based hands-on course on these subjects. I have delivered it now a good few times since I wrote it last year in May. And I had the great pleasure of training approximately 230 data scientists around the world from companies both large and small. Naturally, the classes are small in size, and you spend 5 days working quite intensively, building models, but above all, learning how to validate them. Now, there's probably hardly a more important subject in data science than model validity and being able to tune your models so they become better and better. My closest course to here is on the 7th of November in Chicago. I haven't started promoting them very heavily yet, so I know that except for the London course, which is sold out, the rest still has availability. And of course, it would be an honor to see you there. You can read the syllabus, blow by blow, day by day, module by module, topic by topic description by visiting projectbotticelli.com/courses. And while I'm at it, at projectbotticelli.com/PPT, you can download this PowerPoint, as well as my PowerPoints from Ignite, including the PowerPoint I delivered yesterday on a full day pre-training on Cortana and Azure ML. All right. Let's get started with the real subject. Why do my customers need data science is a question I had to answer for, well, the last 10 years. I have to justify myself every time I start a project. So I have summarized the reasons why my customers need data science into, well, first, a 5,000-word essay, which you are welcome to read. The link is at the top of the slide, and the slides you can download, so you can click on it or make another note. But then I decided that I need to simplify this essay a little bit further, so I have distilled the essence of that essay into these 5 points. Without a moment of doubt, my customers want data science and have wanted it for the last decade to discover reasons why something fails or succeeds that they cannot quite understand. For example, a customer is trying to sell a product. Let's say the customer, a real customer, cannot name it, but you might be able to guess, well-respected worldwide, one of the oldest manufacturers of hi-fi equipment based in Europe, wants to find out why certain speakers are not selling exactly the way they thought they should. Well, they looked and thought, their intuition was well honed, but they weren't getting the answers they were hoping to get. So we put the data through their paces, we build some models, we make sure those models are valid, and in about 20 nanoseconds of cognition, the customer realizes that what they were asking was not the right question. The question was actually looking at a path of connections in a little universe of products that they were making and promoting rather than the speaker itself. The speaker was almost periphery to something far more important that was evading their intuition. As a result of that, 20 nanoseconds of cognition, 10 million euros later, profitability of the company goes up and they have solved something that was bugging them, I suppose. I have customers trying to figure out all sorts of things. Most of the time, they are looking at problems. Some of the time, they are looking at opportunities. In other words, they've done something, it was very successful, but they are unable to repeat the success. Data science helps them find why and how to repeat that success in a meaningful way, in a statistically meaningful way, not just meaningful from a business kind of feeling perspective. Naturally, that means my customers want to understand themselves, their own products, and their own customers better. A customer of mine, a bank in Norway, there are only about 3 banks in Norway, so you can quickly figure out which one, has been doing what most banks have been doing, closing bank branches. But their intuition was telling them, you know, maybe we really don't need to close bank branches. Closing bank branches saves a lot of money, but their intuition was kind of telling them that maybe there are reasons not to do that as, I guess, aggressively as other banks around the world have been doing it. So again, we look at impact of bank branches on customer loyalty, customer profitability, customer risk, and within a couple of days of work, we come up with an absolutely fascinating discovery that yes, closing bank branches saves a lot of money, but it also prevents them from earning money from some of their most profitable customers, especially the older generation, but even more importantly, it builds a problem for them to solve in the future. There was a group of younger customers who were going to become more troublesome for them, expose them to unnecessary risks, and those risks could be mitigated by not closing the bank branches. As a result of that, I can say proudly I have prevented bank branch closures in several parts of Norway because of a simple model that we have built. Everybody wants to plan future more accurately. There are actually Egyptian hieroglyphs saying that we've been business planning future 4,000 years ago, so it's not an exactly new thing to do today. But what is new is that we are now able to do it without relying purely on intuition, and we can apply a scientific approach towards planning future more accurately. But I have a warning to you. If you are a seasoned data scientist, if you've been working in this area for a while, by all means, this is one of the most profitable things you can do. Predicting capacity, future sales, future demand, behavioral changes that will impact on your profitability is very high in demand, and it pays very well to a consultant or a company, or even to yourself if you do it for your own employer. But it is not easy. I would like to warn anybody who is new to this area to perhaps not overpromise too early that with your early data science projects you will be able to improve capacity of financial planning for your customer. The reason for that is that because businesses are so good already at planning future, they are not really asking you to do some simple forecasting. They are asking you, as we say, to move the needle a tiny bit. They want to have a significant but incremental increase in the quality of their forecast. You are not supposed to just deliver a good data science project, you are supposed to beat what they have been doing successfully for quite some time. And that is far, far from trivial. That's why I generally tend to prefer to teach people about data science, suggesting that as a later project. As Americans say, this is not a low-hanging fruit. This is a fruit somewhere in the 3/4 to the top of the tree. For marketing purposes, we talk about it all the time. But when we actually execute on projects, it's better to start with something easier, in my experience. Not a lot of my customers yet, but a good proportion of them use data science to experiment before making decisions. And I want all of you to realize that within the next 5 or 10 years at the latest, this will be the mantra that business people will be constantly talking about. They will be learning about it on MBA courses. The next big thing in business will be that every business person makes decisions first through experimentation. Today, this is a domain of the modern businesses, you know, the millennial or the internet era businesses, the Microsofts, the Amazons, the Netflixes, Facebook, of course, Google. Google, at any moment in time on a daily basis, quoting the words of their own data scientists, are running 500 parallel experiments with different things they want to change. Before Google changes anything, they will experiment, and they have a whole machinery for experimentation. One of my clients who happens to be around here, so I really cannot say too much, but one of my clients who happens to be a very large network of cinemas is just now thinking about putting in place an environment for experimentation so that they can more easily and readily test out crazy ideas that could be profitable to them in the future. I realize that experimentation is tough to understand if you have never done it before, and I also would like to urge you to communicate the value of experimentation as much as you can to your business colleagues. I'll give you some hints how to do it later in this deck, in this presentation. Finally, this is really not happening yet very much widely, but this is very exciting. Experimentation with autonomous decision-making is an application of data science. In other words, I'm talking about artificial intelligence. The models that let us make decisions autonomously are not AI. However, if we include into the loop, if we close the loop, the fact that these models are now being updated autonomously without necessarily human intervention, you are creating, through the back door, an artificial intelligence system that you have built yourself. This is still dangerous. This is still something that makes me a little uneasy if we do not have sufficient human oversight on this type of decision making. But without a moment of doubt, this is how artificial intelligence has already started. So, what am I really talking about? Data science, advanced analytics, or artificial intelligence? I've thrown all of these terms, so let me make some peace, hopefully, with at least some of you who have been struggling, I know, like all of us in our industry, to define or to nail down what they mean. And not from a marketing perspective, but what do they mean from a practical perspective. Let me begin with the easy one, because this one is not really defined in any particular way. People call it whatever they want, but generally, when people talk about advanced analytics today, they mean some combination of data acquisition, preparation, exploration, visualization, and a dose of data science. This is not new. 30 years ago, you would have had a department that acquired data, another department that loaded and cleansed it. You had report writers, and of course you had white-coated PhDs who were the past data scientists, except we didn't call them data scientists. If you worked in a financial organization, you called them quants or quantitative analysts, and of course every industry had its own name for data scientists. What is new today is that increasingly one individual is capable of doing almost all of it, and if not one, then no more than three. What is new is that technology is democratizing this type of analytics so much that your children will be tasked for the homework to build data scientific essays which prove, with some dose of statistical meaningfulness, I hope, that soya production in this part of the world has wonderful impact on livelihoods in another part of the world or not. This is changing. That democratic way of not just trusting someone, but being able to analyze it under the core is permeating every walk of life. So what is then the data science which is part of advanced analytics? It's not just software. It's not just technology. Data science is the application of the scientific method of reasoning to data and analytics. I have studied Foundations of Advanced Information Technology at Imperial College in London. My teachers were Kowalski, McCabe, the guy who invented Prolog, the guy who invented programming in logic. I did not dare to use the term data science until my alma mater decided to use it. And the definition that I decided to run with is the one that makes me feel good. The scientific principle of reasoning is the principle on which our civilization is based. Without it, there would be no modern medicine. There would be certainly no pharmaceuticals. Without it, we wouldn't have been on the moon. Without it, Albert Einstein wouldn't have achieved anything, and possibly even Isaac Newton, although he almost precedes the awakening of the world in terms of data scientific terminology. What I'm talking about is, of course, the idea that you can hypothesize anything. Then, through a process of experimentation, you create facts, and then through that very careful, logical, reasoning step, you arrive at a conclusion. And that conclusion is usually that you should or you shouldn't go ahead with something. Please note, I have not said yes, no. I'm being very careful here with the terminology I use, because as you realize, those of you who have been doing this for a while, that there are no yeses and there are no nos in this business. It's always a maybe, but it is a very measurable maybe. It's a maybe which we can compare to each other. It makes consultants' lives easier too, of course. It's easy to abuse. Of course, technology helps us greatly, and that's where data engineering comes into it, and this is where companies such as Microsoft have made it possible for me for the past decade. Using their technologies, I've been able to deliver data scientific projects long before R and other technologies like that were possible. That's why I feel quite good when I say I am a data scientist, because I don't just build some reports or models or whatever else. I apply the scientific method of reasoning to help my customers make better decisions. And I'll tell you later how I do it and if it does work or if it doesn't work. But let's talk for a moment about technology. In terms of technology, data science is an intersection between a dose of machine learning, or if you prefer data mining, a good dose of statistics, a sprinkling of big data, and an inordinate amount of data wrangling. In case you are new to this, get ready, because 80% of your projects will be wasted on fighting with data. This is why we must use the best data tools we can to save ourselves a lot of effort. I go over and over and over to my customers, and I see that data scientists who are not very familiar with SQL have purchased some technology, no names will be added here, using which they are doing some data cleansing that is taking them days, not just to run, to create. And you know, if you just had a SQL guy in the room, that would have been done like in less than an afternoon. According to O'Reilly Media Research from 2014, 2015, 2016, the #1 tool used by data scientists around the world is called SQL. and I want just that to land and sink in. If you have data scientists who don't like using SQL, don't force them to learn it. Marry them with someone who knows SQL so that on your team you have those two skills. Having said that, not all of data wrangling is bad. I kind of like half of it, because half of it is feature engineering. Is that wonderful thing that keeps you wanting to do the project for the customer. You know, it may be 11 p.m. and you are thinking, oh, if I only add that column, it will really work then. And you probably know what I'm talking about, because of course it kind of answers, but not quite. And you know, at 3 in the morning, you say, that's it. I'm really not fighting with those columns anymore. That's feature engineering, and I like doing it. That's another bit of career advice I like to give to people. If you like feature engineering, you will make a great data scientist. If you don't like feature engineering, find something else to do. Having said that, the other half of fighting with data is not so good. Data is never clean. It's in the wrong format. It has the 99s and the zeros and the NAs and the blanks, and which one are we supposed to use? Data is in a multitude of granularities. It comes from different systems. That I really dislike. This is where I prefer, in an ideal world, to have someone do it for me, of course, but I don't always have that liberty. Again, having the right tools to help you with that part of data science is critical to me being able to price projects at the level the customers want to pay. Big data. Well, you know, we have to have it somewhere on the slide. Big data is, of course, not big data. It's sufficiently complex question with sufficiently complex data. Let me just say that it's usually the smallest part of my projects. It is very important, and I am very thankful to the fact that for the last 5 years I could do, for example, gap analysis for my retail customers using Mahout library running on top of Hadoop and recently moving towards Spark. But this is a small component. And whilst it's very sexy and it's very exciting, I think we may be doing ourselves a little bit of disservice by overplaying the importance of big data. I don't think it is as important as the correctness of the models that we build. One little point to clarify. I'm using the term machine learning and data mining quite interchangeably. Therefore, are they the same? In analytical terms today, the answer is yes, they are the same, but no, they are not the same. They are not the same because machine learning, as you know, is the academic discipline focused on creating algorithms for finding interesting patterns in data, whilst data mining is the application of those algorithms on flattened data to find interesting things that the customer wants us to study. So for all terms and purposes, for the last 10 years, I have been using machine learning to do data mining, which is why those terms are interchangeable. But the reason it's important to observe that there is a difference is because of artificial intelligence. AI is the other huge use of machine learning, which is not really data mining. Even if they are related to each other, those are two different classes of applications today. In terms of people, as you already know, I like the idea of having the data scientist work with a good data expert, not just because of the SQL skills, but also because when I work in my customers' organizations, I need to know where every data point is. I like to work in companies that have a data warehouse, because that gives me a lot of benefits. Notably, data is already pre-cleansed, at least to some level. But more importantly, they have the data warehouse expert, who is universally the person who knows where every data point in the company is. That person is irreplaceable. If you are an organization and you have that guy or girl, keep them, pay them well, because they will be essential to you being able to deliver projects in the future. Of course, you also need to know something about the business. The domain expert is usually the customer. Sometimes it is some other consultant who knows the domain I work in, but usually it is the customer. So that trio, the domain expert, the data expert, and the data scientist, is how I work. I very, very rarely have just two people on my projects. I usually sit in the middle. My data expert is on my left. My data domain expert, is on the right. And I don't know, why, but that's how I like to work. It's very easy for me to be 100% productive this way. Just in case you are wondering about it, why am I not doing my own data preparation? Well, I could, but then I wouldn't be working 100% on building the models, because I would have to spend some of my time doing other things. Therefore, people would be paying the data science salary for effectively getting the data expertise. It is far more cost effective to have 2 people, or indeed those 3 people working together, in my experience. So let me give you an example of a project for a customer in healthcare. One of the low-hanging fruits in healthcare that every hospital that I can think of wants to solve is to reduce readmissions. Readmission is when a patient returns to the hospital prematurely released early. In other words, the patient was in the hospital, the patient was discharged in error, and they have to get back to the hospital. Well, this is unpleasant for everybody involved, but it's also risky. Some readmissions are also very, very costly, especially in countries like the United States, where cost of healthcare is very significant. So hospitals want to reduce readmissions. How do I do it? Well, I go and say, hello, tell me please what is a readmission? At which point the domain expert looks at me and thinks that they hired the wrong person, but don't worry, I am asking that question for a good reason, because I want them to tell me exactly how many days constitutes readmission. And they will typically tell me it's 30 days. This is like a ballpark standard everybody uses. I don't know why 30 and not 31, people just use 30. You know, there's a reason why that was chosen, but it's not a particularly good reason. So I'm immediately thinking, okay, they really haven't done a readmission project yet if they just tell me 30. Why? Because as you realize very quickly, as you build the models, you figure out that actually a different period of time is useful. But we'll come to that in a moment. So my next question is, hello, data expert, show me a row of data that has information about the patient, the treatments, the rooms, the ward, the doctors, anything you can ethically, morally, and legally collect for the purpose of this analysis, plus a flag at the end which says was readmitted, or a column saying number of days since last visit to the hospital. And of course, once I have that, I build my model. Maybe I use a decision tree, my favorite algorithm in general, if I don't know what to use, or some other algorithm, and I build a model. And you know, the model is okay, but the model isn't really that much better than what the customer was already doing. So we scratch our proverbial heads and we think about it, and we say, you know, we have a lot of mishmashed data and patterns here. How about we focus on just a narrower, cleaner subset of data where we can make some interesting proclamations? Dear business owner, could you tell me please if there is a particular type of readmissions that I could focus on my project that you would benefit from? Well, of course, Rafał, if you could just reduce cardiovascular readmissions, that would be amazing, because those are some of the costliest and most dangerous ones. So we clean the data set, we narrow down, and we get a better model. At which point I am seeing in the model that it's okay, but I could make it much better if it wasn't for 30 days, but if it was just for 2 weeks. Knock, knock, domain expert, please tell me, would this model be useful to you if we weren't predicting readmissions within a month, but we focused on readmissions within 2 weeks? Well, of course it would, because those are actually the worst. That's my answer to you working on readmission projects. Why are we using those 30 days? The shorter periods are actually much harder hitting. So that's something I learned after I've done them. Of course, I didn't know that before. And as you realize, at this point, we deliver a model that possibly is working, and it's starting to reduce readmissions. As a result, the data changes. As a result, the model has to change. So from time to time, we keep refreshing it, so it's making different decisions. And the whole loop continues and goes in a nice cycle. Is this artificial intelligence? Yes, it is. I know this is not necessarily the most popular way to portray it, but it is my way, so I want to share it with you. Artificial intelligence is defined differently. One of the shortest definitions that I can share with you from Russell and Norvig is that it's a system that perceives its environment and takes action to maximize its chance of success. Well, in my model of reducing readmissions, the business is changing. The readmissions are reducing. The machine learning models are changing because the data is changing. Therefore, those autonomous decisions that prevent readmissions are also changing. To me, this is artificial intelligence. intelligence. However, it's a slow artificial intelligence. It's slow because there is a human being in the process controlling it and preventing it from doing silly things. When we connect these things without a human being in the process, that is becoming a little bit complex and makes me a little uncomfortable, especially if it ends up driving cars. As much as I enjoy being in those cars, and you know, it's every geek's dream, of course, but you know, I am a little bit worried that maybe it's a little bit too early. But there are places where we are not ready for AI this way. One example is when we are doing things which would be illegal if you couldn't explain them. Classical example is refusing somebody credit. If somebody wants to get credit from a bank, I generally don't like the idea of a system which makes a decision and then the person says, why did you not give me credit? And the person on the other side of the line says, well, the computer said no. You have to be able to explain yourselves. If you are delivering a system that makes any autonomous decisions, or indeed any system that makes decisions, and you feel that you should be able to explain those decisions, don't do it quite this way yet. All right. How do we express the business need in data science terms? So you already know the process, you know how people work, you know what I do, you know what my customers want, but how do I connect those two to each other? You know, data science is the scientific method of reasoning, the hypothesis thinking. And here is a business person who says, please reduce fraud. Well, there is a very simple way that I have discovered, well, no, I haven't discovered, it was discovered by others. I have applied, well, over 9 years ago at least, not on my first project, but I have discovered that it works extremely well. It starts at the high level with a business goal, which I immediately express in terms of a testable hypothesis pair. The classical null hypothesis, which states the status quo pessimistic view, promotion spectacular, spectacular, does not influence our sales. And this optimistic alternative hypothesis, promotion spectacular, spectacular, increased or changed our revenues. Or system X cannot reduce fraud, or system X will reduce fraud by 10%. Those are pairs of hypotheses that I know you can construct. The trick is to construct it at the level that's so high that you can test it. Why couldn't you test it at a lower level? Because you don't have data. You see, the problem is that many people try to start a data science project at a level which matches directly the business need. Sounds like a good idea, except we almost never have the data to test it at that level. The way to solve it is to move up the abstraction layer to the point that you have some data. For example, occupation of the customer seems to influence their lifetime value. Great, well, prove it first, build a model that predicts the customer lifetime value using the customer's occupation as one of the features, as one of the inputs. Test the model, make sure it's significant. Is it significant? Great. You have just proven something at that level. Now make the hypothesis more defined. And as you progress through that, you are going to deliver eventually what the business wants. It's so simple. The idea is not new. I have not invented it. I have certainly applied it on every data science project I have done in the last 10 years. And really, this is the reason I wanted to come here to talk to you. This is the thing that I am sharing with you. Hopefully, you'll find that useful. So let me make it clear. You stage your business problem as a series of hypotheses which are getting progressively more and more defined. From high level to specifics, from data can reduce readmissions to system X that tracks this set of patient characteristics and hospital data and sensor readings, reduces readmissions by 7%. The magic part, which many people don't get straight away, is that you can easily get the data you don't have if you experiment. When you get stuck at a level in your hypothesis at which you no longer have the data to push it down because you haven't looked at the ward number or whether Mycozil was administered after this surgery or not, well, you need to either find that data, if it's somewhere there, or you need to experiment and derive that data. Many people think that experimentation is a way of proving that what we have done works, and that's absolutely true. This is an important testing technique. But experimentation, above all, is a technique for creating the data you don't have, the essential data to get that hypothesis to the level at which it matches what the business wanted. This requires budget. You have to plan for it, you have to pay for it, and I'm sorry to say, but that budget sometimes can be considerable. An interesting point to mention here about big data is that I often find someone who uses big data technologies to say that, well, I don't need to find new data because I have big data. I already have all the data. I'm afraid, in my experience, having a lot of data does not mean we have the right data. In fact, if you have a lot of data, I find that it's harder to find the right data in the lot of data because there is big unnecessary data with very small amount of necessary data. I'm not being critical of big data. Oh yes, I am a little. I am not being hopefully too critical of big data. I am critical of the expectations that we have of the technology. The technology is super and I use it, without which I couldn't deliver my projects. But the attitude cannot be that since I have collected every log, I can answer every question in my company. No, your big data is probably very biased to the way you are collecting the data. Anyway, come on my course, we'll chat about that. What I would like to do now is I would like to give you a couple of demos. You know, it's kind of funny, how do you do a demo of a concept? Because I'm talking about concepts, not technology. So I'm going to give you one demo, I'm going to give you two demos. I'm going to give you one demo in which I will show how I have answered a question for a particular customer of mine and what happened later. And then I will show you how for a different data set, I would answer a slightly different question, also using the process of hypothesis-based thinking. I'm using RStudio, but I could be using Visual Studio Tools for R, which I certainly do use, and I just started this project a little earlier, I guess. And this is, of course, a great demo because RStudio is not loading. Oh, that's funny. Okay, let's see if we can open it in a Microsoft tool. Microsoft will absolutely love this. Oh, sorry, Microsoft, RStudio decided to load. Oh, okay. Just in case you are wondering, I am using Microsoft R Server over there, but it's not really necessary for this purpose. This is a little bit like using a cannon to shoot a little bird, but never mind. This is a project from a real customer, as it happens in healthcare. Healthcare is only about 20–25% of my business, so please don't think that everything I do is related to healthcare. A lot of my projects are in commerce, in retail, in finance, in insurance, in banking, but healthcare is important to me in many ways. Anyway, what I want to show you is the data set. This is a real data set representing admissions to hospital for elderly patients, some of whom are not suffering from dementia, and unfortunately, some of whom are suffering from dementia. The question is, with all of this data, can I somehow confirm or not that the patient's length of stay in the hospital was different for those who have dementia from those that don't? My customer in this case was expecting that patients with dementia stay longer in hospitals. By the way, this is a very real data set. Look, spelling mistakes, what is a 99 versus a blank, why an A, no, yes, blank, you know, this is what we live with all the time. So I got very excited about this project, and of course I immediately tried to do what I need to do, which is to plot the data first. I love visualizations, and by the way, you must see tomorrow's speaker, the keynote speaker. Edward Tufte is the king of visualizations. How do I visualize the answer to this question? Well, with something as useful as a box plot. Let's visualize using, actually, you know what? I'm going to save myself time and using the history feature, I'll just bring back the last one. Using ggplot2, I will plot Length of stay converted to a number +1. Why? Because there are zeros. Yes, length of stay is logarithmically distributed, so that's why I'm logging it around, so it's easier for you to read. Data coming from this data set, jcc.clean, and I'm going to break it down by the factor of whether the patient has or hasn't got dementia. And of course, I expect to see that patients with dementia have a significantly higher length of stay. And I need to load the ggplot2 library, of course, first. And there we go, and we get a nice pair of box plots, which are showing us, well, first of all, that yes, the median for patients with dementia is higher than the median for patients without, which is why I understand that my customer was quite excited with this data. But unfortunately, I am quite sad at this point. Can you see why am I sad? Because, in case you haven't used box plots for this purpose, because the box plot tells me that the notches are overlapping. If you ever wondered what are those notches on a notched box plot, the notches tell you how significant is the difference in the medians. And it's telling me that even though the median stay for my patients with dementia is higher than those in the control group, unfortunately that difference is not meaningful because of the spread of the data. The notches are overlapping. And without having to do anything else, I can go back to the customer and at this point say, I'm really so sorry, but with very simple analysis, I failed to reject the null hypothesis. And if they don't understand this terminology, I basically tell them, sorry, but based on the data you gave me, there is no significance to your thinking that patients with dementia stay longer. So at this point, the customer, of course, is unhappy and comes back and says, well, Rafael, can you find something in the data that gives us a hint? Oh, you know, this is called data dredging. In other words, if you don't get the answer you want, search for an answer you can give the customer. This is not a very good practice. Of course, in big data, it's practiced all the time because you start with the data and then you find a question you can answer, but that's another story. Let's just go... Thank you. Let's just go back to this customer and say, what can we do here with this data? Well, I am very careful not to give them any proclamations that would be very hard and lead to decisions because it's inappropriate to use this data set to answer questions it was not designed for, or at least that's how I have been trained, but I will look for reason. So the way I look for reason in this case is by writing a tiny bit of R. This is like 36 lines of code. Most of it is gaps and comments and whatnot. Nothing really complex. All I'm going to do is I'm going to loop through different values of the length of stay, and I'm going to perform a chi-square test to see whether there is a particular cutoff value of a length of stay at which I see some meaning in the data. Let me run that through for you because what I see at this point is a very interesting plot. What I am seeing is that there is no meaning most of the time in the data, but at this point over here, at length of stay of approximately 16 days in the hospital, we are barely scratching the surface of the commonly accepted level of statistical significance. By the way, I do not use the criterion of 0.05 p-value as a rule. I always choose the value that matches my customer's attitude to risk and appetite for what it is they want to do. I work with p-values which are way smaller and way larger than that. But we are clutching at straws here. The customer wants something, so we are using that criterion. And we say, dear customer, even though your hypothesis that patients with dementia stay longer than those without cannot be conclusively, I guess, taken to where you wanted it to be, if you redefine your question and you ask for patients who stay too long in a hospital, define too long, 16 days or longer, something starts appearing. The mist is still hanging there, but I can see through the mist. And at this point, I can go back to the customer and say, dear customer, using this data, I cannot conclude anything more, but I recommend that you do a new study in which you collect the data in your hospitals just to see whether patients stay more or less than 16 days and come back to me later again. And that is part of the process. Part of the process is that sometimes you will fail to reject the null hypothesis, and that is as educational and as important to the customer as rejecting the null hypothesis. Failure, so to speak, is part of what we do. Let me give you a second demo in which I have a more hypothetical data set. This is actually a data set that is used, that we use for teaching people data science. If you come on our courses, you'll get a copy of Happy Cars. This is a data set in which I am trying to show a technique for churn analysis, but churn analysis with a twist. I am not going to discuss it in as much detail as the previous example, but I want to give you a hint. I'm using SQL Server Data Tools and SQL Server 2016. This is what the data set looks like after a little bit of feature engineering, where I see that customer 11004, that is Elizabeth Johnson, by the way, if you are wondering, born in 1968. I do know my data set. Customer 11004 bought a car, then received a neutral, then a happy service. Customer 11006 bought a car, then had a neutral service. Neutral means they were, neither happy nor unhappy. This is a 3-point scale. 2-point scales are better, but in this case we have a 3-point scale. Using the technology that's old, SQL Server Analysis Services data mining, I can easily build a model using Microsoft sequence clustering algorithm. This is a very interesting algorithm that I have been using for advanced analytics for almost 10 years. This is why I have been able to do it before R and before Microsoft re-awoke, so to speak, to data science. Of course, this is old technology, and R and R server are much better, but I still like it because it's visually extraordinarily useful. It visualizes cluster similarities. It gives me the cluster profiles, shows me their characteristics, discriminations, and my favorite, free of charge, I get a state transition diagram, which tells me in this analysis that, let me just maybe reorder it for you, that customers who get happy service, I only churn 3% of them. Those who get neutral service, I lose 11% of them. But look at this. I lose 20% of customers who get unhappy service. This is churn analysis with an explanation. Because I have multiple clusters of customer behavior, each of which I can analyze for transitions, not only can I say, yes, customer satisfaction matters greatly to churn, but I can also operationalize it to predict why a customer will churn, rather than this customer will churn with a 20% probability, which is what you typically get from churn analytical systems. Here you are, two simple examples of how hypothesis-based thinking helps me deliver tangible, real-world business projects. That is not quite all. I still have to go to the real-world experimental stage. I still have to try it out. I still have to deploy my churn system and target a group of customers for whom I see how it is acting, and I have to compare with a control group where my system is not being deployed, and after a period of time I have to compare that my system is really working better than not using the system. That real-world experimentation stage is essential. Why? Because of closing of the loop. You see, when you build a machine learning model, you are building it from the past. You are not really predicting, will my customer churn in the future? You are predicting, would my customer have churned in the past? Today is different. As a result of that, the model may be just slightly worse or slightly better, but the model also may be completely wrong, especially if the actions of the model influence itself. I was talking to a lady from a world-famous airline yesterday, and it was a very interesting situation where a model they were building was valid, but the actions of the model had bigger impact on their load factors than the business expected. As a result, they were increasing the load factors, but they were decreasing the revenues. This is a classic situation that we cannot eliminate unless you do a real-world experiment. That experimentation is different, subtly, but it is different from experimentation needed to derive data. Does it work? Yes, it does. Everything I have just described to you is known in business as data-driven decision making. And one of the most wonderful studies of this concept was conducted at your own very American MIT and Penn's Wharton School of Business back in 2011 and updated in 2012. It was found that 189 out of Fortune 500 companies derive between 5 and 6% of their bottom line revenues, not profits, revenues, only thanks to making data-driven decisions. You know, we are talking about multi-billion-dollar businesses. 5 to 6% of that is a lot of billions of money with a fairly significant level of statistical validity within 1 sigma. What that means to me is that if you read this article, and my link will give you the whole article, not just the abstract to the article, you will find some of the best way to convince the non-believers that data-driven decisions work. That is a huge validation of the idea. Unfortunately, it's only 1 study, and we need to wait for more studies and for time, of course, to prove itself. So we need to be suitably cautious about it. But this idea of hypothesis getting down to the level that business can benefit from them works really, really well. Does that mean I am suggesting we remove human innovation and human instinct from the process and replace it with data? Absolutely not. Indeed, quite the opposite. We need human intuition to make crazy decisions. In other words, if you want to promote sales of milk by introducing scuba diving suits in your grocery stores, it's a real project. Yes, we've done that. Trust me, it's very interesting to do strange projects. Does it increase sales of milk? Yes, but it also increases sales of everything. So that's a different story. And hence, that's another project. If you want to do that, you have to have a human being who just thinks these things up. AI doesn't do art. Some people say never, some people say not yet. We're not going to discuss that now. With that human intuition comes a big risk. The risk that the decisions you will make will be the wrong decisions. Well, that's where I come in. This is where advanced analytics lets you validate the facts, and data science enables this process. As a result, my decision makers can be freer to have newer ideas that nobody else tried before, because I provide them with a safety net of that meaningful thinking and experimentation so that they can think up more ideas. That is why business will be so excited about this concept in approximately 5 to 10 years from now. Well, you are the early swallows of this change, and I hope that that idea will help you achieve those goals. But don't wait. Gartner says that by 2020, 10% of organizations will have a specialized unit for productizing commercial data this way. Ladies and gentlemen, in summary, I hope I have managed to explain to you why data science is a science. I put science back into the business by using the scientific method of reasoning. And it's not difficult. A hypothesis iteration as a mechanism for progressively solving a business problem works. And it's also a wonderful first step towards artificial intelligence in an applied world, in case that is one of your goals. I hope I will have a chance to meet you again, whether on one of my courses where we drill these ideas for 5 days, or online, or even around here today or tomorrow. But right now, I would like to thank you for your attention and wish you a lot of success with data science. Thank you.